Hello, everyone. My name is Todd Westhauser. I'm a hardware engineer at Facebook, specifically the lead hardware engineer on Delta Lake. And I've been working with John Bryan, who's a platform architect at Intel, specifically the platform architect for Whitley and Cedar Island, which are Intel's next generation Cooper Lake platforms. I'm here today to talk a little bit about Delta Lake, which is a one-socket server for Yosemite V3, which is Facebook's next generation compute server platform. And I'd like to begin by telling you a little bit more about the CPU we'll be implementing on Delta Lake. So in the bottom right, there is an image of a prototype of Delta Lake. So the CPU for Delta Lake is codenamed Cooper Lake, and it's a third generation Intel Xeon scalable processor. This Cooper Lake CPU provides enough PCIe lanes to provide solid bandwidth for Delta Lake's network interface, as well as two separate expansion options, which you can see in the image below. On the far left, there is a front expansion option for a 1OU form factor, and the top left, there's a riser card expansion, which allows for a 2OU expansion option if a 2OU blade fits your application. Cooper Lake also offers some increased AI performance versus previous generations, since it implements a bfloat 16 floating point format. The bfloat 16 offers nearly equivalent prediction accuracy as a 32-bit format, but it requires less power and improves the overall throughput. The philosophy behind this is it provides acceptable accuracy while using fewer cycles. And one other thing I'd like to point out about the base Delta Lake is while there are expansion options, even in the default configuration, there are still slots for two local M.2s, as you can see in that image on the right. So I'd like to talk a little bit more about Delta Lake's architecture specifically. So I'd like to begin by starting with the CPU again. So it supports a number of DDR lanes. This can support either the DC persistent memory modules designed by Intel, named Barlow Pass, or your standard DRAM, depending on your application. There's also a number of PCIe connections, which will either go to those expansion connections I mentioned earlier, which are the riser expansion and the front expansion, as well as to the rear baseboard connector. The rear baseboard connector connects to what we call the baseboard, which supports the BMC as well as a multi-host NIC connection if you're using a multi-host NIC in your application. And lastly, on the PCIe, there is an M.2 that connects directly to Cooper Lake. Unlike the other M.2, which I'll get to in a minute, this is not necessarily a purpose-built M.2 and can be used for a variety of applications. Cooper Lake also connects to the platform controller hub through a DMI interface. The PCH, or platform controller hub, will load the BIOS through a SPI interface based on our SPI flash. And you can also use that same SPI interface to use a TPM 2.0 module that we've implemented on the board, which allows for storing of measurements of various firmwares that we load on the system. The PCH will also connect to the purpose-built boot M.2, which will hold a lot of the system software and operating system. It's also got USB interfaces and an LPC and SM bus interface to the bridge IC. The bridge IC is essentially an extension of our BMC, which exists on each blade, as opposed to a single BMC, which will exist on the baseboard and support up to 4 blades. The BMC will manage some local temperature sensing over the SM bus, as well as the through EEPROM. The through EEPROM will hold device-specific information such as serial numbers, which allows us to identify individual boards. Lastly, the bridge IC will use USB, IPMB, I2C, and UART to communicate with various devices on that baseboard. But the primary connections that it's going to have there are to the BMC itself. I also wanted to highlight some of the versatility of Delta Lake and how we've kind of made our Yosemite V3 platform able to support a lot more configurations than we had in previous generations. So in the top left, we'll have what I've been calling the base Delta Lake configuration, which is just kind of a web tier server. This blade will only have the Delta Lake on it, and it'll also be connected to the baseboard and VMC through that connection I mentioned earlier. This is just kind of the bare bones option, and it has a lot of room for expansion, as you'll see in the other options. Directly below that, there is a Delta Lake with the 10U expansion. That 10U expansion can support up to 4 22.110 M.2 devices, depending on whichever type of M.2 device you particularly like for your application. Using the 10U expansion, it still supports a multi-host NIC, like the standard web tier server, and can support up to 4 blades per baseboard in each sled. If we move to the right, you can see there is a new 20U expansion form factor. This will allow for a couple different things that vary from the original web tier or 10U expansions. If you look at the top right, there is expansion for up to 6 more M.2 22.110 devices. And then if you look at the image below that, when you remove that top riser connection, you'll end up with a 10U blade that has a single host NIC as opposed to a multi-host NIC that was in the previous configuration. Additionally, in this 20U expansion configuration with a single host NIC, that leaves each of these sleds with its own BMC, which will manage each blade. What that results in is 2 BMCs for a sled as opposed to just the single BMC for 4 blades like we previously had, and single BMC for 1 sled. Thank you for taking the time to listen to my presentation on Delta Lake. If you'd like to learn more, please reach out to me or John, or anyone on our Facebook and Intel team, and they should be able to point you in the right direction. So I would now like to open this up to Q&A.
Hey everyone, this is Todd. Please let me know if you have any questions. I'll try to answer them. John is also on the line and he'll be here to help as well. So I've got one question coming in from Peter. The question is, in the 20U configuration, can the accelerator board take dual M.2 modules? If so, how many dual M.2 modules per CPU? So there will only be a single CPU in this configuration, and it can support dual M.2 modules. In this configuration, we should be able to support up to 6. A question from Uma. The URL for this information should be in the handouts section of this presentation. And I think that question was also about the full specs for Delta Lake. We have not currently published the Delta Lake spec, but we are planning to do so in the fall of 2020, excuse me. So it looks like we have another question, which is what is the total server power? We're targeting around 150 watts per blade. If we go up to the sled level, which can support up to 4 OU, we're looking at closer to 650 because we have some overhead with the baseboard. Let's see, does anyone have any further questions? Okay, I'm not seeing any further questions, but I will still be around for a few more minutes if anyone has any more, or feel free to reach out to me outside of this presentation. Okay, thanks for attending. And again, feel free to reach out if you have any more questions.